Boys and girls, this is Mr. Manice here again with another super cool video. In this video, I'm going to walk you through how to solve each of the problems on the factoring and quadratic formula quiz review. My disclaimer, as always, I need you guys to work these problems on your own, and then and only then a Jedi will you be. Then and only then can you come to the video and watch the problems and see what mistakes or misunderstandings you may have. So let's jump right in here. Number 1, number 2, and number 3, and number 4. What do you notice about all 4 of these problems? There is nothing there. There's nothing there. There is no equal sign here. They are simply asking us to factor. We are not solving anything. I'm not trying to figure out what goes in for m, okay? I'm just trying to simplify the expression, all right? When I have a trinomial, okay, the first thing I'm thinking of is it a special case? Let me back up. Before I factor any problem, I always want to see, can I pull out a GCF? That's number 1, okay? There's no GCF here because that's a 1 there, and then that doesn't have an M, okay? So it's not a GCF. If it's not a GCF problem, I look to see, is it a special case? If there's 3 terms, the only thing it could be is a perfect square trinomial, and I'm looking to see, is that a perfect square? The front term and the back term, are they perfect squares? Yes, no. Okay, so it's not a special case. Then I move to say, okay, if it's a trinomial, what are the factors of this guy that add to this guy? What are the factors of negative 54 that add to negative 3? And hopefully it won't take you guys too long to figure that out. That's going to be a 6 and a negative 9. And so this just factors as m plus 6 and m minus 9. It doesn't matter which one I write first. 2 times 3 is the same thing as 3 times 2. So it doesn't matter. Now, if you want to check these on your calculator, remember the trick that I've taught you guys. This is a very, very important trick, something I'm very, very big on. When you do not have an equal sign, guys, you can type in the original expression. This works for exponents, radicals, polynomials, quadratics, cubics, all kinds of stuff that we'll get into later in advanced algebra. Type in your original expression, type in your simplified answer, and then make sure these two guys match. So the way I taught you guys was to assign a number to every letter on your calculator. So I'll type in exactly what I see here. Alpha m squared minus 3 alpha m minus 54, and I get some number. Okay, guys, I don't care what that number is. I don't care what it is. Negative a million, scientific notation, negative 1.6, I don't care. I just need a number. And then let's type in, we're saying that's equivalent to m plus 6, m minus 9. So parentheses, alpha m plus 6, close the parentheses, open parentheses, m minus 9, close the parentheses, and they better match. And when I press enter, voila, there you go. If these two numbers match, that means that these two guys are the exact same thing. We have simplified it correctly. Okay, so please, 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 I'm begging you guys to use this little trick when you're factoring these problems. Okay, the next one here, some of you guys probably look at that and go, huh? Do what? What do I do when there's an M and an N? I'm normally used to seeing just an X. What do? I want you guys, when you see something like this, I want you to imagine that the N is not there. Okay, just covered up. Let's just pretend this was m squared minus 8m plus 12. Okay, I'll rewrite it here. Just treat it like a normal problem. What are the factors of 12 that add to, there's no GCF, it's not a special case. What are the factors of 12 that add to negative 8? That's negative 6 and negative 2. So this is going to factor is m minus 6 and m minus 2. Okay, we say, wait a minute, Mr. Manice, there's an n here. Okay, well, if there's an n there, where do you think that the n goes? There's only really one spot it could go, right there on the back end. Okay, so anytime you have two variables like this, one of your variables is going to be on the front, one of your variables is going to be in the back. Doesn't that make sense? If I refoil this back out, first, outside, inside, last, okay, and then I combine those like terms, m squared minus, excuse me, that's a 6, sorry, that was a 6. Combine the like terms, minus 8mn plus the 12n squared, and you notice we'll get right back where we started, okay? Okay, so let's move on, and of course you could check that. For sake of time, guys, I'm not going to check every single one of these on the video. I'll let you guys do that. Actually, you know what? Let me go ahead and do that, because this is a perfect example of why I've taught you guys to assign a number to every letter. Okay, you could just use X, so you could just put a number. You just plug in X for 5, but this is a case where you got two different variables. So this is why I like to use the different letters on the calculator. So let's type in the way we see it. So alpha m squared minus 8 alpha m alpha n plus 12 alpha n squared. Okay, I just need a number. Okay, fine, whatever, 1377. I want to make sure that that is equivalent to my simplified answer, which is alpha m minus 6 alpha n alpha m minus 2 alpha n. Okay, they better be the same thing. What do you know? They match. And guys, that is such a great feeling when you have confirmed you've got a winning lottery ticket in your pocket that says you did it right. You don't have to ask, Mr. Maniz, did I do this right? You don't have to check the solutions online. You know you've got a tool in your hand that will guarantee that you've done it correctly. Okay. Let's keep going. Number 3. Okay, well, when I see two terms, guys, that's got to be, you got to get in the habit of immediately recognizing that that's a difference of squares, what we learned last year in geometry. This is a perfect square. Okay, that is a perfect square, and there's a minus sign between them. Therefore, I have a difference of squares. These two guys are squares. When you have a difference of squares, then you take the square root of the first term, that's x. You take the square root of the second term, don't worry about the negatives. Take the square root of the second term, that's 9. Okay, and then you're going to have one of your factors is positive, one of your factors is negative. So it's going to factors x plus 9, x minus 9. Okay, that's it. One binomial is positive, one binomial is negative. That's it, you're done. Okay, number 4, can I pull out a GCF? No, that's a 1, that doesn't have an x. Is it a special case? I'm always looking to see, can I take the shortcut? In this case, you look to see, is the first term in the trinomial a perfect square? Yeah, I can take the square root of x. Is the back term a perfect square? Yeah, I can take the square root of 16. That's 4. Now here's the catch though, guys. In order for it to be a perfect square trinomial, when you multiply these two factors, the factor of that guy and the factor of that guy, when you multiply those, you must be able to double it and that equal the middle term. So when I multiply 4 times x, 4x, when I double that, do I get 8x? Yes, I do. So if you can answer yes to that second question, then all you got to do, guys, is just throw a parentheses squared around it and then bring down the sign. If that's a plus, that's a plus. If this had been x squared minus 8x plus 16, it would just be x minus 4 squared. Okay. And of course, we could refoil this back out just to confirm. I'll do that very, very quickly just so you can see. X times x, x squared, outside 4x, inside another 4x, last 16. And that's why, guys, you say you got to double it. When you multiply x times 4, when you double it, you get the middle term. You double it because you're literally getting 2 of them when you FOIL it out. And when you combine those, you get back to where we originally started. Okay, x squared plus 8x plus 16. All right, let's check that one real quick. Okay, here I am going to use the x's, x squared plus 8x plus 16. Get a number, fine, whatever. We think that's equivalent to x plus 4 quantity squared. Oh, look, they match. Boom, go on to the next one. Okay. A lot of students will make a mistake on the difference of squares. They'll say something like this is equal to x minus 9 squared. And if you check that, you'll see it doesn't work. X squared minus 81 gives me a number. And if you type in x minus 9 quantity squared, that doesn't work. They don't match. Okay. So that lets you know, hey, I did something wrong. Okay, now notice on the rest of the problems, guys, you see that little bad boy right there? That is an equal sign. Okay, so now we are actually solving. Here we are simply factoring. Okay, now we're actually trying to solve. I'm trying to figure out what number can I stick in for k so that when I square k and then I add 12 times k and then I add 31 to that, that will equal -5. What number goes in there? Okay, so when I'm solving, guys, I want my quadratic set equal to 0. So the first thing I want to do, and I always want the squared term to be positive. Don't ever have like a negative k squared or negative x squared. That just complicates the matter. So I'm going to go ahead and add the 5 to both sides. Okay, those cancel. All right, so I have k squared plus 12k plus 36, okay, equal to 0. Okay, GCF? No. Special case? Well, can I take the square root of those two terms? Yes, I can. Square root of k squared is k. Square root of 36 is 6. When I multiply those 6k and double it, do I get the middle term? Sure do. Throw a parentheses squared around it and bring down the sign. So your final answer is k plus 6 squared. Okay, now that's the simplified form. That's how it factors. All right, now we actually have to solve this. So all of my equations are going to be set equal to 0. So if I solve this, I basically have k plus 6 times k plus 6 equal to 0. So I've got to set each one of these guys equal to 0, but since it's squared, you only have to do this once. If I set k plus 6 equal to 0, I get k is equal to -6. That's why I say when this front coefficient right there, when you get down and factor it and you get your final binomials, when that front coefficient is a 1, you just flippy flip. I just change this sign. Okay, so I get k is equal to -6. All right, now this one's a little bit different when you want to check your answer because I can't just type this in and make sure it matches. So when there's an equal sign, you actually have to physically take this number and plug it back in for k. So watch how this works. Okay, so everywhere I see a k, I'm going to stick in a -6. Now this is a negative, so I got to put that in parentheses if I'm going to square it. Parentheses -6 squared plus 12 times -6. Sorry, I have to make sure I can see that in the camera. Plus 12 times -6 plus 31. That better be equal to what? Whatever's on the right-hand side of the equation. Most of the time it's 0, but in this case it's a number. That better equal -5. Okay, and it does. So check. Boom. Move on to the next problem. All right, number 6. All right, I want this guy, I want that squared term to be positive, so let's move both of these guys to the other side. I'm going to add the 15k squared. I'll subtract the 8. And y'all should just be able to do this in your head, but I'll do it anyway. So I'm going to have a positive 15k squared plus the 14k that's already on the left-hand side minus the 8 that I moved to the other side. Okay, how do I factor this? GCF? No, nothing that goes into both 15 and 8. It's not a special case because neither the front nor the third term are perfect squares. Can I factor when a is 1? What are the factors of 8 to add to 14? No, I can't do that because this term, that guy right there, is not 1. So when a is not equal to 1, that front, remember our standard quadratic equation is ax squared plus bx plus c equals 0. When this guy right here is not a 1, it's something other than 1, 2, -6, 1.8, whatever. When that guy's not 1, I must do the rainbow thing. Okay, I've got to multiply a times c. Okay, 15 times -8. 15 times -8 is equal to -120. Okay, so this is a temporary, so you're going to come out here to the side. This is a temporary number that I'm going to use to split this middle term. So the next step is once I do a times c, the rainbow thing, I got to figure out what are the factors of -120 that add to 14. Ugh. Okay, that's a lot of work to list out all the factors. Well, here's where we can use another calculator trick. And so I'm simply going to go to my y equals right here, y equals, and then type in the big number that you're trying to find factors of. Guys, you don't need to type in -120. In fact, I think that just confuses you. I just want the number, okay? So just type in 120 divided by, oops, sorry, take 2. 120 divided by x. You are telling your calculator, I want you to take 120 and I want you to divide it by 1, then 2, then 3, then 4, and your calculator is going to come up with a list of values. So you go second table, right here, the table button. And now, and by the way, just in case your table, sometimes I'll see students that have a really wacky, kind of jacked up table. See this button right here that says table set in blue? If you go second table set, you want to make sure your table is starting at 0. Okay? And then you want your table increment to be in 1. Sometimes I've seen this table increment in 500. Students don't know what the heck's going on. So make sure you're starting at 0 and an increment of 1. Okay, so let's go back to second table. And now I'm looking for factors of -120 to add to 14. And so when this number is negative, that means one has to be positive, one has to be negative. That means, in other words, I need two numbers that multiply to give me -120 that are 14 apart from each other. It'll somehow get me to a 14. Okay, two numbers that are 14 apart from each other. Okay, there you go right there. Okay, we've got the 6 and we've got the 20, right? Those are 14 apart from each other. Now I got to figure out which one is positive and which one is negative. the sign of the middle term determines the sign of the bigger one. So since that's positive, this is going to break down into a positive 20 and a negative 6. Okay, so now is where I'm going to split this middle term, and we're going to factor by grouping. Okay, now it doesn't matter whether you match up the 20 with a 15 or the 6 with a 20, the 6 with a 15. I'll do the 20 since they're both divisible by 5. That makes sense to me. So I'm going to rewrite this as 15k squared. I'll put the 20k over here, and then I'll have the negative 6k, and then I just bring down the negative 8. So all I've done, guys, is I've taken $14, I've taken 14k's, and I split that into 20k's and minus 6k's. That's still 14k's, or $14. Now I'm ready to draw my curtain and group. I can pull out a GCF. So you're pulling out the greatest common factor on the left. They both are divisible by 5, and they both have a k. So, and again, this should all just be review from geometry from last year. So I'm going to factor out a 5k. Okay, to figure out what's left over, I've got to take each of these terms and divide it by the GCF that I pulled out. So your brain should be doing this little mini step in your head. You're basically dividing each of these terms by 5k. 15k squared over 5k, that's going to leave me with 3k. 20k over 5k, the k's cancel, and I'm just left with plus 4. Okay. On the right hand side of my curtain, guys, when that front term is a negative, I don't care about the second term. When that front term has a negative, I must pull out a negative GCF. They're both divisible by 2, so I've got to pull out a negative 2. Guess what? That's also, these two parentheses binomials, they better match. So that's also going to leave me 3k plus 4. Just double check. Negative 2 times 3k, yep, that's negative 6k. Negative 2 times 4, yep, that's negative 8. Okay, so notice that these binomials match, and that's good news. That means we're on the right track. So one of my factors is 3k plus 4, okay, the matching binomial. My other factor is going to be the stuff left over outside the parentheses. I've got and there's no sign there. Of course, that's understood to be a positive. But there's a negative, so it's going to be 5k minus 2. Okay, now remember, that's how it factors. Okay, but now we've got to set it equal to 0. So I've got to set each one of these guys to 0. I can't just flippy flip because that coefficient's not 1 and that coefficient's not 1. So I have to set each of these little expressions equal to 0. And hopefully you guys can get to the point where you can just do this in your head. Okay, first thing you do is just move that guy to the other side. So I'm subtracting 4. 3k equals negative 4. And then I'll divide by 3. So one of my answers, one of my solutions is negative 4/3. And then I've got to do the same thing over here. I've got to set 5k minus 2 equal to 0. Add 2 to both sides. 5k equals 2. Divide by 5. And so my answers are, my solutions are negative 4/3 and 2/5. Okay. Now, how do I check this with a fraction? No different. I just take this guy and I plug him in here for k. Now you can plug it into the original equation. I like to just go ahead and plug it into the equation set equal to 0. That's just me personally. So I'll show you guys how to do this real quick. Okay, let's get out of here. All right, so let's type in, make sure y'all can see this, 15k squared. But what is my k? My k is negative 4/3, so I got to put that in parentheses. Parentheses negative 4 divided by 3. I'm going to square that. Okay, and then plus 14 times k, which is negative 4/3. You can put in parentheses if you want to, you don't have to. And then minus 8, and that better be equal to 0. And it does. And of course, you could do the same thing with the 2/5. So guys, please, I'm begging you, especially in advanced algebra, there's a lot of stuff in advanced algebra that we will be able to use these calculator tricks that I'm showing you to guarantee that you're getting the right answer. Okay. Number 7. Okay, I only see 2 terms. So when I see 2 terms, I'm thinking, oh, is that a difference of squares? Well, negative 8 is not a perfect square. So the first thing on our list is always to see, can I pull out a GCF? Okay, do they both have something in common? They do. They both have an m. So I can factor out an m. That's going to leave me with m minus 8. Okay, now our 0 property product from geometry says if 2 things multiply to give you 0, one of those bad boys has to be 0. So it's either that guy or that guy. So I'm going to set each one equal to 0. If I set m equal to 0, I literally get 0. And then here, since that coefficient is 1, I can just flip the sign, 0 and 8. That's easy, GCF. Okay, next one here. I've got a negative squared term, so I want to move this guy to the other side. Okay, so that's going to give me a positive 2x squared. Write it in standard form. It's always your ax squared term, then your bx, then your constant. Okay, 2x squared plus 6x minus 36 equals 0. Okay, so can I factor this? Well, a is not 1. Okay, so you're probably thinking, ooh, I got to do the rainbow thing. Oh, that's going to give me a big number. But what's the first thing, guys? What's the first thing you always ask? What can I do? Can I pull out a GCF to make my life easier? What do you know? They're all divisible by 2. So if I factor out a 2, that's going to leave me x squared plus 3x minus 18. Now this is a trinomial where a equals 1. And you might be asking, well, what happens to this 2? Where does it go? It goes away. It disappears. If I divide both sides of the equation by 2, 2 over 2, that's just 1, and 0 over 2 is still just 0. So whenever you factor out this GCF in these equations, these GCFs, they just go away, they disappear, okay? Unless there's an x, okay? If you factor out an x, that's different. But if you just factor out a constant, that constant just disappears. So now this is easy. What are the factors of negative 18 that add to 3? What are the first two numbers that pop in your head when you think of 18? I think of 6 and 3. Okay, does that get me to a 3? Yes. And since the middle term has a positive sign, the bigger one's got to be positive. So this is going to factor as x plus 6 times x minus 3 equals 0. Both coefficients are 1, so flippy flip. X is equal to negative 6 and positive 3. That is your answer. Okay, so I'm going to write GCF. Factor out that GCF always, if you can, guys. Make your life easier. Now, if you went ahead and did the rainbow thing and multiplied the 2 times the negative 36 and got a 72 and split, guess what? You will still end up with the same answer. You just did it the longer way. Okay, let's keep going here on the back. Number 9. Okay, we're in standard form. That's good. That's not 1. It's not a perfect square trinomial because 2 is not a perfect square. I can't pull out a GCF because 7 is not divisible by 2. So here, yes, I do need to do the rainbow thing. 2 times negative 30 gives me negative 60. So I've got to figure out what are the factors of negative 60 that add to, sorry, I can't see that. What are the factors of negative 60 that add to 7? Okay. Now most of you guys can probably do this in your head, but if not, that's okay. Go to our calculator. Let's type in 60 divided by x, and let's go second table. And since my c is negative, since this temporary number is negative, or excuse me, I shouldn't say since my c is negative. Since a times c is negative, that means we're basically looking to see the factors of negative 60 that are 7 apart from each other. 7 apart. Here we go, 5 and 12. Okay, so this is going to break down into 5 and 12. Since the middle term is positive, that's going to be a positive 12 and a negative 5. All right, so let's split this. Let's split this middle term. Where do you want to put the 12? Let's put it with a 2. Doesn't really matter. 2x squared plus 12x, and then minus 5x. Bring down the minus 30. So I've just split $7 into $12 minus $5. Still the same thing, but now I can draw my curtain and group. Pull out a GCF of 2x. That is going to leave me with x plus 6. What do we do, guys? What do we do right here? When that front term is a negative, you must pull out the negative with it. Okay, so they're both divisible by 5, so I'm going to pull out a negative 5. That better leave me with x plus 6. Does it? Negative 5 times x, yes. Negative 5 times 6, negative 30, yes. So these two guys match. That's good to know. So one of my factors is the matching binomial, the x plus 6. My other factor is the stuff left over on the outside, 2x and minus 5. We're setting this equal to 0. Now that coefficient is just a 1, so we can just flippy flip. X equals negative 6. Now that's not, so we got to solve that. 2x minus 5 equals 0, so 2x equals 5 divided by 2. So my other answer is 5 halves. Negative 6 and 5 halves. Okay, let's do one more of these real quick to check. Well, I'm telling you guys, once you get good at this and do a bunch of these, you'll be able to do these in 15, 20 seconds. Let's do the 5 halves. Let's do the harder ones. So 2 parentheses 5 divided by 2 squared plus 7 times, I don't need parentheses, 7 times plus 7 times 5 halves minus 30. That better equals 0. What do you know? It equals 0. Boom. Go on to the next one. Okay, number 10, I don't have it set equal to 0, so let's move the 4 to the other side. So I have 14m squared plus 19m minus 3 equals 0. That's not a perfect square. I can't pull out a GCF, so I got to do the rainbow thing again. 14 times negative 3, a times c gives me negative 42. And now I'm looking to see what are the factors of negative 42 that will give me to 19. If that's negative, one's positive, one's negative. Okay, so once again, if you're not good at doing those numbers in your head quickly, 42 divided by x, second table. I'm looking for numbers that are 19 apart. There it is right there, 2 and 21. Since that term is positive, that's going to be a positive 21, and then the negative 2, the 2 will be negative. So let's split this. I'm going to match up the 21 with a 14, both divisible by 7. All right, so I got 14m squared plus 21m minus 2m minus 3 equals 0. Draw my curtain. I can pull out 7m. That will leave me with 2m plus 3. That front term is negative, so all I can do, guys, is pull out a negative 1. That better leave me with 2m plus 3, and it does. Negative, negative. All right, so one of my factors is the 2m plus 3, and my other factor is the stuff left over on the outside. 7m minus 1 equals 0. And you really, guys, you really should get to the point where you can just do this in your head. Okay, just visualize this as an equation. Visualize that this is equal to 0. You move 3 to the other side, that makes it a negative 3, divide by 2. So that's going to be negative 3 halves. Move the 1 to the other side, positive 1 divided by 7, that's going to be positive 1/7. Okay. Let's move on. Quadratic formula and breaking down these radicals. Can we do it? Yes, we can. All right, so number 11, we've got quadratic formula. If you want to sing the song, quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. All right, sorry, I just have to do that. Okay, so just like we sang in class, and so again, like I taught you guys, I'm a big advocate of making sure the webcam is focused. And then I'm a big advocate of coming over here to the side and listing out your A, B, and C. Okay, it's in standard form, that's good news. So my A is 4, my B is negative 12, my C is negative 9. That way you don't have to really think about it anymore. It's just plug and chug. But be careful here, it's negative b, but your b is already negative. So it's negative 12 plus or minus the square root of, again, this is negative. So when you square that, make sure you're putting that in parentheses if you're doing that in your calculator. Minus 4 times a times c, negative 9, all over 2 times a, or 2 times 4. Okay, negative 12, that's going to make that a positive 12. And then here, guys, I find that a student is kind of really not sure what to do here. As long as you put this in parentheses when it's negative, guys, just type this into your calculator. Just type in it exactly the way that you see it. Don't leave it up to chance and getting your signs wrong or right. Now, if you're doing this manually, then of course you'll say, okay, that's 144. Negative times negative is a positive, or you can just type it in. Negative 12 squared minus 4 times negative 9, and just do it on your calculator. Boom. Square root of 288 all over 2 times 4, which is 8. And now the hard part. Okay, we've got to leave our answer in simplified radical form. So, could we just type this in as a decimal and just get one decimal? Yeah, of course. But there is a skill involved to be able to break down these radicals. That is a critical thinking skill that is good to learn and enhance. So let's come over here to the side and let's break down the square root of 288. Okay, how do I do that? Well, the first thing you're asking yourself is, what is the highest perfect square that goes into this number? Okay, let's come over here off to the side and list our, maybe down here, let's list our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, etc., etc. These are our perfect squares. 1 squared, 2 squared, all the way down. So you're asking yourself, which of these perfect squares, what is the highest perfect square that goes into my big number? Well, I doubt a lot of you guys can do that in your head with such a big number. Okay, so once again, here's where we can use our calculator and go to y equals. I'm going to do the same thing. I'm going to type in my number, 288 divided by x. Just like we're trying to find factors, I'm going to press second table. And now, guys, I'm looking to see your highest perfect square could be in the x column. Most of the time it's in the y column. I'm looking for a 64, an 81, a 49. I'm looking for those numbers in this column. And do you see that anywhere? Actually, I do this time. The second number right there, 144, that's one of our perfect squares. That's just 12 squared, okay? So in this case, they were nice to us. It was a little bit easy. I can break down, the way I taught this last year in geometry, if you didn't have me last year, I taught this as perfect land and non-perfect land. So you're going to break this down into the perfect land, so you're going to break that down into the perfect square root, which is 144, and then I got non-perfect land over here. That's the square root of 2. So 288 breaks down into 2 and 144. This goes on the perfect side, this goes on the non-perfect side. I can take the square root of 144. I can't take the square root of 2. That's why I throw it over here on the right. Square root of 144 is 12, so that simplifies to 12 root 2. Okay, so now back over here, when I see the square root of 288, I'm going to rewrite that as 12 plus or minus 12 root 2 all over 8. Okay, all I did was I replaced the square root of 288 with 12 root 2. But now notice, guys, that these three numbers, the two numbers on the outside and the number on the bottom, if they're both divisible by the same number, you can simplify it further. So 12, 12, and 8 are all divisible by 4. So if I divide those by 4, that's going to give me 3 plus or minus 3. Treat the root 2 like an x. You don't do anything with that when you're trying to simplify those three numbers. And then 8 divided by 4 is 2. Okay, so I get 3 plus or minus 3 root 2 over 2. Okay, now again, some of you guys might be saying, well, how in the world do I check this, Mr. Maniz? It's some crazy answer, some irrational answer, right? Well, it's some decimal. All of this comes out to be some decimal. So if I wanted to check this, it's quite easy. I'm just going to go ahead and convert all this mess to some number. Okay, so I'm just going to use the positive form. Yes, there are two solutions. 95% of the time in quadratics, you're going to have two solutions. So let's just get a number here. Let's just go 3 plus 3 root 2. Let's just get a number. Let's divide that by 2. Okay, so we're saying that one of the solutions is positive 3.6. The other answer, of course, is going to be the negative. If we do 3 minus 3 root 2 over 2, it'll give us some other answer. But let's take this answer and let's plug it in for v, and let's see what we get. So I'm going to press 4. I want my second answer. Y'all see this button down here? A and S in blue? That means answer, okay? So I want the answer that I just chose. So I'm going to do 4 times my answer, go second answer, and then I'm going to square that, minus 12 times this answer, so second answer, minus 9, and that better be equal to what? That better be equal to 0. What do you know? So yeah, you can check these all day long. Okay, let's go on to the next one. I'm in standard form. My A is 5, my B is 6, my C is negative 3. And so we've got negative B plus or minus the square root of B squared minus 4 times times C all over 2 times A. That's going to be negative 6 plus or minus. Do all this on your calculator. I don't need to put that in parentheses because it's positive. 6 squared minus 4 times 5 times negative 3. Okay, 96. Square root of 90. Remember, that's under the radical. So square root of 96 all over 10. Now, how does the square root of 96 break down? Perfect land and non-perfect land. Okay, let's go to our trusty calculator. 96 divided by x, second table. And let's see if we find a perfect square in here. 48, no. 32, no. 24, no. 16, there's one. But remember, you want the highest one. So let's keep going and see if there's anything else higher. Okay, I don't see anything else. Okay, so that is going to be my highest one. So this is going to break down into 16 and 6. 16 is the perfect size, so that goes on the left. 6 is the trash or the non-perfect land that goes on the right. And so that just simplifies to 4 root 6. Square root of 16 is 4. So I'm going to replace root 96 with 4 root 6. So that's going to be negative 6 plus or minus 4 root 6 all over 10. And then notice that all three of those guys are divisible by 2. So that will give me negative 3 plus or minus 2 root 6 all over 5. Okay, let's keep going here. Let's keep going. 13, we're not in standard form. Let's move that 4m to the other side. That's going to be 3m squared minus 4m minus 12. My a is 3, b is negative 4, my c is negative 12. So it's negative b, negative negative 4, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's going to make that a positive 4 plus or minus. Let's type all this in the way we see it. Second quit. Of course, you know that negative 4 squared is 16, so you could just go ahead and type in 16, of course. But negative 4 squared minus 4 times 3 times negative 12. That gives me 160. That gives me negative 160. Okay. So that's 160 all over 2 times 3, which is 6. Now, how does 160 break down? Go to y equals, type in 160 divided by x, second table. And let's start at 0. Let's see if we can find a perfect square in here. There we go. There's a 16. 16 and 10. Okay, so the square root of 160 breaks down into the square root of 16 and the square root of 10. Square root of 16 is 4, so this is just 4 root 10. So I will replace the root 160 with 4 root 10. That's going to give me 4 plus or minus 4 root 10 all over 6. Notice that all three of those are divisible by 2. So then divide those by 2. That gives me 2 plus or minus 2 root 10 all over 3. Okay. All right. Now let me just digress here for just a second and go through what happens. What happens if you didn't pick the highest perfect square? Because I know that sometimes that happens to you guys where you think you have a perfect square, but it's not the highest one. Actually, I'm gonna totally digress here. Let's just do this on a sticky note. Let's say I'm trying to break down the square root of 72. And let's say some of you guys broke this down and you said, okay, well, 4 definitely goes into 72. 4 goes into 72 18 times. Okay, and that's correct. 4 times 18 is 72. And you say, okay, the square root of 4 is 2, so this breaks down and this simplifies to 2 root 18. If that radical still has a perfect square in it, if it still has 1, 4, 9, 16, 25, if it's still in there, divisible by any of those numbers, that means you didn't pick the highest one. Okay, so from here you got 2 options. You could either go back to the drawing board and go back and start from scratch and say, oh, okay, yeah, 72, the square root of 72 breaks down into the square root of 36 and the square root of 2, and the square root of 36 is just 6, so you get 6 root 2. Okay, or the other option is to keep going from here. Let's just ignore the 2 for a second. The square root of 18 still breaks down further into the square root of 9 and the square root of 2. And the square root of 9 is just 3, so this is 3 root 2. But then I'm multiplying that by 2. So if you multiply those together, 2 times 3, you get right back to the 6 root 2 number. Okay, so just wanted to throw that out there in case you guys came across that. All right, last one, quadratic formula. This is pretty easy. So just as a side note, by the way, guys, you would not have to use quadratic formula to do this. This is just a good old-fashioned square root method. I would just divide both sides by 12, take the square root of both sides, and boom, there's my answer. However, it says to solve it using the quadratic formula. So we say, okay, fine, we can do that. All right, so let's get this set equal to 0. 12n squared minus 20 equals 0. Okay, so my a is 12. What is my b? There is no b. There is no n term, so b is 0. C is negative 20. So we've got negative b, negative 0, plus or minus the square root of 0 squared, minus 4 times a times c all over 2 times a. Okay, so that's that goes away, but the plus or minus doesn't go away. Okay, so of course that's just nothing, but you got to keep that. So this is going to be plus or minus the square root of, that's going to be negative 4 times 12 times negative 20. That gives me 960. Square root of 960 all over 2 times 12, which is 24. Okay. Now, how does the square root of 960, how does that break down? Let's go to a calculator. 960 divided by x, second table. Start at 0 here, and let's look for a high perfect square. Okay, keep going. None of those are perfect squares. Oh, there's one right there. Boom, 64. 8 squared is 64. That's one. So I could break this down into 64 and 5. Square root of 64 is 8, so that's just 8 root 5. Okay, so this is going to become plus or minus, don't forget the plus or minus 8 root 5 over 24. Notice that the 8 and 24 are both divisible by 8. So that's just going to give me plus or minus the square root of 5. Oh, why I keep saying 5? I don't know why I keep saying 5. This is 15, I'm sorry. 64 and 15. Plus or minus the square root of 15 over 24 divided by 8 is just 3. So plus or minus the square root of 15 over 3. Okay, last couple ones, these are easy. All right, so this says find the discriminant, and so the discriminant just means the b squared minus 4ac part of our quadratic formula. And then it says state the number and the type of solutions and the number of x-intercepts. And guys, this is going to be the way exactly verbatim the way it's going to look on the actual quiz. So you've got to tell me the number of solutions and the number of x-intercepts, the type of solutions. Are we talking about real? Are we talking about imaginary? What are we talking about here? And I know we haven't gotten to the imaginary yet, but we'll get there soon. Okay, so the discriminant here, again, I would still come out here to the side and list the a and the b and the c. All right, so my a is, we're in standard form, a is 10, b is 6, c is negative 14. So I'm just going to do b squared minus 4 times a times c, type all that into your calculator. That comes out to be 596, okay? So when that value, guys, is positive, go back and look at your notes if you need to, and the discriminant is positive, that means I am going to have a quadratic that's going to cross the x-axis in 2 spots. I'm going to have 2 real roots. I'm going to have 2 real solutions or 2 real roots, however you want to write it. And the number of solutions will always equal the number of x-intercepts that you have. But on the quiz, I need you to write both of them. 2 real solutions and 2 x-intercepts. Okay. All right, number 16. All right, I got to move this 8 to the other side. So x squared plus 16x plus 64 equals 0. By the way, this is a perfect square trinomial. But if I just do the discriminant, let's go ahead and list these out. A is 1, B is 16, C is 64. So I have B squared. Sorry about that. B squared minus 4 times A times C. Okay, so if you do that, that comes out to be 0. Okay, so when your discriminant is 0, that means you have a quadratic that's going to come down and barely touch the x-axis in just one spot. Okay, so I'm going to have 1 real solution and 1 x-intercept. Okay, number 17. Let's get it in standard form. 8v squared minus 5v plus 4 equals 0. A equals 8, B equals negative 5, C equals 4. Probably helps if you guys can see it on the camera, huh? Okay, so my discriminant is going to be B squared minus 4AC. That's going to be negative 5. I'm squaring that. Minus 4 times 8 times 4. That comes out to be negative 103. Okay, so when my discriminant is negative, guys, I don't have an x-intercept. Okay, so I have 0 real solutions. Now on the quiz, if you guys want to write 2 imaginary solutions, I'm perfectly fine with that. Technically that's a better answer anyway. 2 real solutions, or excuse me, 0 real solutions and 0 x-intercepts. Or 2 imaginary solutions and I still have 0 x-intercepts. Okay, last one, home stretch. Move the 21 to the other side. 4x squared minus 21 equals 0. My A is 4, my B is 0, my C is negative 21. So B squared minus 4 times A times C, that comes out to be 336. That is positive. So when I have a positive discriminant, I have 2 x-intercepts. So I have 2 real solutions and 2 x-intercepts. Okay, that's it for this video. Hope you guys enjoyed that, and I wish you good luck on your quiz, and we will see you on the next video.